All right, we're continuing with section 9.1, 9.2, our last few videos here. So before we were graphing the lines associated with our system of equations. Now we're actually going to be solving for the intersection between the two. And these are two different lines, y equals 2x plus 4, y equals 2x minus 4. But they have the same slope, so that's problematic. Now, if you think of the line y equals 2x plus 4, let's go ahead and graph a few points. So if you put in a 0, you get the y-intercept, which is 0, 4. And if you put in like a minus 2, now I'm thinking about what zeroes this out. You get a 0 for the y. This is actually the x-intercept, which we've talked about a little bit. So 0, 4 is our y-intercept. Negative 2, 0 is our x-intercept. And so if you draw a line, then that's our first line. Now our second line, 2x minus 4, has a different y-intercept and different x-intercept. So let's do this. So put in a 0, you get a minus 4 for the y-intercept. And if you put in a positive 2, then you get the 0, the x-intercept. Now with a line, you're always going to have one y-intercept, one x-intercept, unless it's a vertical line. Okay, so let's graph that function now. 0 minus 4 is down here, and 2, 0 is up there. And here we go with the graph. Now, the problem with this set of lines is they are parallel, and parallel lines don't intersect. So just graphing this, we have a sense of already there's a problem. And so it's not that there's an infinite number of solutions. There is no solution. They never intersect. So no solution. So that's one of our cases. A system can have no solution at all. All right, let's do another one. That was kind of like solved by graphing. And now we're going to solve by what's called substitution. So again, a system of equations, if they are parallel lines, and then we'll get no solution. But we want to do this a little bit differently. So what we want to do is solve for one of the variables and substitute it into the other equation. Let's grab this equation right here. Let's solve for x. I mean, it's easy because just bring the y over, and you have the plus 4. So x is equal to y plus 4. So we take this equation and we plug it in where the x occurs in the second equation. So we have 9 times y plus 4 equals, plus a 6y has to equal negative 99. And now we solve for our new y. Now, there's a little work to do. We have to distribute. We need to combine, bring stuff to the left-hand side, stuff like that. Let me make this a little bigger. I have a little more room to work. Excuse me 1 minute. All right. Now, so back to solving this equation. So we have 9y plus 36 plus 6y equals negative 99. So combining the 9y and 6y, we get 15y. Bringing the negative 36 over, we get negative 36 like that. So we get 15y equals negative 135. Now, you might need your calculator. You might know your multiples of 15, but I would just go ahead and be careful there. So negative 135 divided by 15, it goes in there evenly, negative 9 times. So y equals negative 9. Okay, so y is equal to negative 9. Now, you take this answer and you plug it back into the x equation. Alright, so you're plugging the y in that spot right there, and so you get negative 9 plus 4. So x equals negative 5. Those are our two, that's our solution. Our solution to the system is an ordered pair, and we write it with parentheses, and you go minus 5, comma, minus 9. Alright, let's keep doing this. That's called the substitution method. Now there's another method called the elimination method. Alright, so that's what we're doing next. So stay with me. That was number 4, by the way. Alright. Number 5. So the elimination technique is a little bit different just in the kind of concept that we're working on. Same goal, we're trying to find an x and a y that satisfy both of these equations simultaneously, the intersection of the two lines, if they in fact have a single solution. They could have no solution, they could have an infinite number of solutions. Alright, let's jump in and do what we can. So the idea with elimination is you want to use the fact that these equations are equivalent to add them together to cancel one of the variables. Alright, now we have to do some work though. So right now, if we added these two equations together, nothing would cancel. We would just get 5x and negative 15y and 10. That's not what we're wanting. We're wanting to add the two equations, but we want it to eliminate a variable. So what we're going to do is we're going to multiply this equation, both sides, by a minus 3. And we're going to multiply both sides of this equation by a positive 2. Now the idea is to get the same coefficients up front but opposite. So the first equation, so this becomes 6x. Be sure to distribute 30y equals 12. The second equation becomes minus 6x, a positive 30y equals negative 12. All right, now, so there's a few things that happen here, and so this is one of these at first it seems a little disconcerting, but when you add these together, you get 0 plus 0 equals 0. I'm adding the equations together, and so 0 does equal 0. So, but unfortunately, we've eliminated all the variables. Now, this doesn't mean there's no solution. It actually means there's an infinite number of solutions. These are the same equation. They didn't look like it, but they're the same equation. If you run a negative through there, you get the exact same equation. They don't. I mean, this 3 and this 2 make this look a little bit different. These are the same line, the exact same line. So there's an infinite number of solutions, and this equation tells us that 0 always equals 0. So there are an infinite number of solutions. Now, what are those infinite number of solutions? Well, they have a little second, so they say x, comma, what. It's a little annoying, but you gotta take one of your original equations and solve for x. So let's take. It doesn't matter which one you pick. Let's take the 2x minus 10y equals solve for y. Sorry, solve for y. So so you get negative 10y equals negative 2x plus 4. And then solve for y, divide by negative 10, so you get negative 2 divided by negative 10x plus 4 divided by negative 10. Stay with me here. So that's a positive 1/5 x minus 2/5 after simplification. So if x is anything, y just has to be 1/5 of x minus 2/5. Seems a little strange, I know, but what we're saying is any pair that satisfies this line will work because they're the same line. Now, if you solve for y in the first equation, you're going to get the exact same line. And anyway, you should do that to check it. Now, this has a special name. The system is consistent. Consistent in the sense that it doesn't violate any rules of numbers. I mean, 0 does equal 0. But we say it's a dependent system. So it's consistent in that there's no contradiction. We'll see here in a second a contradiction. It's consistent but dependent. All right, I'm going to stop the video there. We'll pick up where we left off in just a minute.